Okay, today is our last shape of the unit, circles. They are actually my favorite shape. Circles are so cool. Circles are actually not a polygon, right? Because by definition, a polygon has to have segments, it has to have sides. And a circle doesn't have any segments, doesn't even have any sides. I'm going to go on a tangent real quick and talk about what a circle actually is. These pictures that I have up here, these are not, that figure is not a circle, because that's a circle shaded in. A circle, by definition, and you don't need to write this down, a circle is a collection of points, a given distance from a center. So you have a center, you have a point, which is just a location in space, that's what a point is, and you pick a distance, so let's say 2 inches, and you collect all the points in the universe that are 2 inches away, that was a bad circle, sorry, from that point that you picked. How many points are 2 inches away from my point? An infinite number of points. But when you collect all of them, when you collect all the points that are a given distance away from that point, then you create a circle. The inside of that, that's not the circle. That's just the interior of the circle. The actual circle is just like the edge. You can't call it an edge. But anyways, that's what the definition is. It's a collection of points that are equidistant from a given point. All right. Familiar formulas to you. You've already seen these before. For circumference, you may use 2 pi r or pi d, where r represents the radius and d represents the diameter. Sometimes the first one's more useful and sometimes the second one is more useful. So we will use these interchangeably, and you will find those on your formula chart. No need to memorize. A lot of you actually have already memorized it. Area. The area is pi r squared, pi times the radius squared. You don't want to accidentally use the diameter. Remember, the radius is half of the diameter, so we're going to make sure we use the radius. Math majors exchanging high pies. Haha, get it? Instead of a high five, you give them a high pi, and make sure you put your pinky up a little bit, right? Because pi is 3, but a little bit more, 0.14. Okay, anyways. What is pi? What is pi? We're going to watch a short video from Night at the Museum about pi, and then we'll talk about what pi is and what pi isn't. It's better than not watching it at all, right? Okay, so what's important to know about pi, and we'll talk about where pi comes from, but pi is a number. That's really important. Pi is not a variable. Pi is not a unit. Pi is a number. So your answer to a problem could look like 15 pi meters squared. Pi is not your unit, okay? Just because it's a letter, Greek letter, does not mean that it's a unit. It's actually a number. So what we're not going to do ever, 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 ever is square pi. There is never a reason to square pi, so don't ever square pi. Maybe in the future you'll need to square it, not in my class, okay? Let's talk about what pi is. So we have a circle with, well, I kind of was a little off there, with a given diameter, right? Okay, we have a circle with a given diameter. Now, if you were to take that diameter, and stretch it around the circle, how many diameters would it take? It would take 3 diameters and a little bit more, right? It would take 3 diameters to stretch around this circle. That's actually what pi is. If I were to solve this problem for pi, I would get pi equals circumference divided by diameter. So pi is just a ratio. It's just a really, really fancy ratio. Does that make sense? It's any circle in the universe, take the circle's circumference, divide it by the circle's diameter, and you will get 3.14159.265, on and on and on. Pretty cool, huh? So since this number is so famous, since it comes up so often, instead of writing that long number every time, we gave it a name. It's like a celebrity. You know how some celebrities, like, they don't use the name that they were born with, Lady Gaga or whatever, Madonna. They are given like a new name when they reach celebrity status. Well, this number, it reached celebrity status, so they gave it its own name. So pi is just the name of this number. It is a number. You'll learn in a future math class, you'll learn about e, and it's also a really, really special number, so popular that it got its own name. Okay, enough background, Miss Stanton. Let's just solve some problems. Maybe. Emily is riding bikes with her daughter. I was riding bikes with my daughters just a few days ago. Emily's bike is a 23-inch bike, which means, by the way, you measure a bike when it's advertised, that is the diameter of the wheel. So 23 is the diameter. Her daughter's bike is a 16-inch bike. How much further does Emily's bike travel with one revolution of the wheel than her daughter's? So what are we looking for here? What kind of value? Looking for the area of a circle? No, yes, of course. We're looking for the circumference. So we want the circumference of Emily's bike minus the circumference of her daughter's bike. Well, this is easy because they gave us the diameters. So the circumference is pi d, pi times diameter. So this is just 23 pi minus 16 pi. Notice, did I go to my calculator and do 23 times 3.14 and write the decimal down? No, I did not. Just like we don't go to our calculator and type in radical 3. We keep it exact. We keep it in terms of pi is what this is called, in terms of pi. So in terms of pi, Emily's circumference is 23 pi and her daughter's is 16 pi. If we subtract those, the exact answer would be 7 pi inches. That is the exact answer, and that's how you're going to answer these problems most of the time. Now, this one's unique because it's a real world problem, and that doesn't make much sense to us. We don't go around talking to people like, oh, the length of this is 7 pi. No, we use an actual approximation of that exact number. So then I go to my calculator and I type in 7. I'm not going to use 3.14. We're going to actually use the pi button. We're going to use the pi button every time. We're not going to use approximation. So I type in 7, then I type the pi button. Does everyone know where that is on their calculator? And you get 21.99 inches. So pretty much these are approximate, her wheel travels 22 inches more every time. So her daughter is going to have to do a lot more pedaling to keep up with her mom, right? Okay, so this is called in terms of pi, and this is the rounded answer. Next example, the circumference of a circle is 30 pi. Find the area. Okay, guys, the circumference is 30 pi. So we, of course, know we can use either formula. Circumference is pi times diameter, or we could have used 2 pi r. But if we cancel these pi's, oh my goodness, okay, that's easy. The diameter's 30. Now to find the area, we never ever use diameter. We of course need to get our radius. We know that a radius is half a diameter. It's diameter divided by 2. So our radius is 15. So we do pi r squared. Pi times 15 squared. And then we go to our calculator. We know that 15 squared is 225. For some reason, the numbers just trade places. So the answer is 225 pi. Do I put it in my calculator and write down a decimal? No, it's not a real world problem, so we do not press the pi button. We keep it exact. Find the circumference of the circle. Uh-oh, what'd I throw at you? An inscribed hexagon, huh? So to get the circumference, we either need a radius or a diameter, right? We need that. Okay, so we're going to start off by drawing our favorite triangle. I'm going to work this quickly because I know that this is a pretty easy problem. We've got 9, we've got 9 root 3, and we've got 18. Right? Which one of those is helpful to us? Good. 18 is the only number we care about. 18 is the radius of the circle. We need to find the circumference of the circle, so we double 18. We don't forget pi. We don't have any units, so we don't put units. Cool? We needed the radius. It helped us find the diameter, and then pi d. Okay. Find the area of the shaded region. On problems like these, when you're finding area of shaded regions, I like for you to write a strategy first. And it might seem silly on these that are really easy, but it'll help you, that strategy, on the ones when they get a little bit tougher. So our strategy is, I want the area of the larger circle minus the area of the smaller circle. Kind of just gives you somewhere to start. Okay, I can start by finding the area of that large circle. So do it. Find the area of the larger circle. All right, the area of the larger circle is 49 pi. That's all there is to it, guys. Pi r squared. R is 7. Pi r squared. The area of the large circle is 49 pi. Okay, now let's find the area of the small circle. To find the area of the circle, you need a radius. The radius is 3.5. So the area of the smaller circle is pi r squared. So we need to square 3.5. You could also square 7 halves. That would be fine too. 12.25 pi. Okay, now are these like terms? Yeah, they both are in terms of pi. So they are like terms. So we're allowed to subtract them. We are not supposed to keep them separate. We are supposed to combine them. 36.75 pi is the final answer. You're also welcome to write it as a fraction. 147/4 pi. Multiple choice problems, you might see it as a fraction as well. Okay? Good job if you got that. Good job. All right, let's try 2 more. We have 2 more left. Find the area of the shaded region. We need a strategy first so we know where to start. We're going to do area of something minus area of something. You always, of course, do the area of the larger shape minus the area of the smaller shape. All right, so we want to do the area of the circle minus the area of the square. Area of the circle. Throw it at me. That one's easy. Area of the circle. Oh, Leah beat you to it. Pi r squared. 16 pi. Okay. Area of the square. Area of the square. We did one like this actually in the regular polygon lesson on Monday. We did this on Monday. 4 root 2. The area of a square is side squared. 32 is the area of the square. Is that okay? 45, 90. X root 2. Okay. All right. Now, for the first time in the lesson today, those are not like terms. One's in terms of pi and one is not. I want you to keep it just like that. 16 pi minus 32. If you did have units, you could put the units afterward if you wanted to. But that is the final answer. 16 pi minus 32. No, you don't combine them. No, you don't subtract them. That's the exact answer. Last problem. Find the exact area and perimeter of the shaded region. I am going to add something to this. For the perimeter, we are only going to do the outer part. Okay? So for perimeter, we're only doing that section right there. I'll let you think about it for a minute. The way I looked at this one is that I looked and tried to figure out how many circles am I dealing with? How many full circles do we have? One and a half, right? Yeah. We have 1.5 because we are, by the way, I didn't say this, you are allowed to assume that those are semicircles. You're allowed to assume that they are half circles or else we couldn't solve it. So we have 1.5 circles total. So if I can find the circumference of one circle, I can just multiply it by 1.5. If I can just find the area of one circle, I can multiply it times 1.5. Okay? So let's do that. Let's find the circumference of one circle. Let's see, AB is 16. What is that? Oh, that's the diameter. So pi d, 16 pi, that's the circumference of one circle. But there's 1.5 circles. So 24 pi inches. Pi is not the units. All right. The area of the shaded region, well, let's see, the radius is 8. So the area is pi r squared times 1.5. So it's 64 times 1.5, because there's 1.5 circles. 96 pi inches squared. Cool? Good?